All right, guys, here's our second example. And in this example, we're also calculating a probability. So it's helpful to draw a picture. So that's the first thing I'm going to get set up. So just draw a bell curve. I like to draw mine in two pieces because they're kind of difficult. I get a little crazy on the right side if I try to do it all in one piece. But what I do is I label this axis on the bottom, this horizontal axis, using whatever variable that it represents. So in this problem, we're talking about x, and naturally the x-axis does go from left to right, but in some examples, they're going to give you variables like v or w, and you just kind of roll with it. So if you really want your picture to match up with your problem, just pay attention to little details like that. Okay, and as always, you want to draw a line right down the middle, which is your mean. And in this case, our mean is 20. Okay, and the other value that we really want to look at is 16.6. Okay, and that's a value that is provided to us. So 16.6 is to the left of 20. And don't worry about how accurate you are with your spacing. It's more or less a visual for you to wrap your head around what it is you're trying to find. And so that's all this sketch is really representing. So we're trying to find this probability, and this part is really key for you and your understanding. You have to shade in the value that is less than or equal to 16.6, which would be to the left right here. So as you can see, we're finding a very small portion. So our probability this time, remember from the first video, the probabilities that lie to the left and to the right of this line are both 50%. So this whole piece is 50% and this whole piece is 50%. So we know that the portion that we're trying to find is going to be less than 50%. Okay, and I like to have that as like a checks and balances going on in my head so I understand if my answers make sense. Okay, so we're going to get right into this by first calculating our z-score. So we have to standardize this using that z-score formula, where z is equal to x minus mu, which is your mean, divided by your standard deviation. Okay, so z is going to equal 16.6 minus our mean, which is 20, divided by our standard deviation. So remember, they give us the variance as 7. So to find the standard deviation, you take the square root of your variance. And if you guys just type that right into your calculator, you are going to get a negative value this time. So it's negative 1.285. Okay. And that is not our final answer, but I put like a little squiggly under it because it kind of helps me know that that's a pretty big milestone in me finding my probability. I also want to point out the fact that this is a negative z-score. So I'm going to come back to my picture for a second and put these z-score values underneath the corresponding x values, okay? So the mean always has a z-score of 0, okay? And this 16.6 just got a z-score of negative 1.285. And what these z-scores represent are how far to the right or to the left that value is from the mean. So if you get a negative value, it just means that that x value you're trying to find is to the left of the mean. And that makes sense, okay? So when I go to find my probability now on my probability distribution table, that z-score table, I'm not going to find, if you take a look at it real quick, notice that all of these z-score values just range from 0 to 3. There's no negative numbers here, okay? So if we look at this picture, we'll kind of understand why, is because all of these values that they provide you in the table are everything that's to the right half of the mean, okay? But since this curve is symmetrical, we can use the right side to find the left side, okay? So all we have to do is kind of come back to, come back to this problem for a second. And we're going to take this z-score and we're going to make it positive. okay? And when we set this up, I'm not going to do it just right away and just make it positive because I want to make it positive. If I write this out, I want you guys to see the steps here that it takes. So we're asked to find the probability x is less than or equal to 16.6. Well, first and foremost, we want to put that into perspective, and we want to change that into a z instead of an x. So we plug in the z-score that we found, okay? And what we're going to do, if you kind of glance back at this table for a second, they tell you what to do with negative values. It's right here. Hold on a second. There we go. It says for negative values for z, what you're going to do is you're going to take 1 minus your probability, okay? So, hold on, bear with me. Here we go. All right. So, if I take 1 minus the probability that z is less than or equal to, but instead of making this negative, what I do is I switch this to a positive value. Okay, and what that's doing is you're taking the complement, and we've been doing complements all the time. We just came off of the binomial distribution where you have the probability of success versus the probability of failure, and those are complements, and that's exactly what we're doing here. So I am going to locate this z-score, the positive 1.285, on that table and then plug it back in here. So let's flash back for a second and figure out where 1.285 is. Okay, so we've got 1.2, your first 2 digits here. The next number we need is 8, because 1.28, and we also have a fourth number, 5. So the first thing that we do is we find this cross section of these first 2 numbers, and we start with that value, and then we're going to add a 9 to it. Okay, so I want you guys to think about this. We have, instead of it being, I'm going to write this off to the side, I drop the decimal and I write 8997 and I add a 9. Okay, if you have the decimals included, it just gets to be too much and it's too tricky. This is very straightforward. And if you do this and you add these up, sorry, I'm reading my notes. So I have a 6, you can carry that, boom. You got a 1, boom, boom, right? I love it. Okay, so then I put my decimal right there. Okay, so it turns into 0.9006. Makes sense. All right, so let's take this value and we're going to carry that back into our equation, and 0.9006, right? And that should give us an answer of 0.0994. And that, guys, is our answer for that. And I do want to elaborate just a bit so you guys can really see the symmetry here of like switching from a negative to a positive. When we look at the negative 1.285 and where it correlates on there, think about this. Like if I go equally spaced over here and go 1.285 this way, what I just found is, first of all, the probability of this whole piece here, right? That first number that I pulled, that probability was the 0.9006, which makes sense because that's a really big probability. That's more than 50%, okay? So it's like 90%. The answer, though, that we were trying to find and that we were asked in this problem is this piece here, right? It's the smaller piece, which is the exact same as this over here because all of these bell curves are symmetrical, and symmetry is a huge part. So by subtracting that value from 1, that gave us the probability of 0.0994. Okay, and so you can see kind of how all that plays out. So I hope that helps explaining the negative z-scores and all that good stuff. All right.